Hello everyone, my name is Francesco and together with Michele we have developed this project. Our project focuses on a tool that serves two purposes. Predict the cervical cancer based on individual, lifestyle and medical history, and analyze an image of cervical cells obtained during clinical examination to detect the presence of tumor cells. Our main objective was apply as much as possible what we learned, what we gained during this journey at data science retreat. So we used classical machine learning techniques for data classification. We used computer vision to analyze images. We used explainable artificial intelligence, which allows the user to understand which part of an image had contributed to a specific outcome. And we also integrated the OpenAI API to the text generation. For the user interface, we created a web interface using Flask. At the beginning, it's a little bit complicated, but it offers a great flexibility and freedom in development. So we customize each page using HTML, CSS, and JavaScript functions to handle some specific interaction. The first part regard its concern the risk prediction. We first explore the data to understand which feature were most correlated to the target. And then we clean up the data, also removing feature that had no correlation to the target and feature with inconsistent values. As mentioned before, the feature relate to lifestyles and medical history. We had 4 targets for different diagnosis technique, and we combined it together to obtain only 1 target. However, the minority class was very small, around 10%. So we tried different various technique to balance the minority and majority classes. Techniques like undersampling and oversampling. And then we try different algorithm also using the Lazy Predict library that allow you to compare quickly many different algorithms. And this is our interface, simple and flat. And by clicking on the predict the risk button, you access on this page with a grid, labels, and input cells. If there is some difficulty to understand which value to be entered, we provide 2 pages with all information. For example, smokes years doesn't mean how many cigarettes you smoke in 1 year, but how many years you smoked. And then we have 2 examples. We have a woman, 51 years old. She has the first sexual intercourse when she was 16, 2 pregnancies. She doesn't smoke, and she used an intrauterine device for 1 year. She has a sexual transmittable disease, in this case HPV, the human papillomavirus, and we see that in this case the risk of cervical cancer is high. And on the other hand, we have a 40-year-old woman, first sexual intercourse when she was 18, with 3 pregnancies. She smokes for 8 years, so since 8 years, an average of 24 packs per year, and she uses hormonal contraceptive. She has no sexual transmittable disease, and we see theoretically, that in this case the risk is high. So maybe the combination between cigarettes, smoking, and hormonal contraceptive have a higher impact on the prediction, on the risk.
Aims to evaluate the outcome of basically pap tests. So pap tests give this kind of images taken at the microscope, which are cells. And these cells can be indicative of presence of cancer, or they can be healthy. So to train our models, we used the CPACMed data set, which is publicly available. And yeah, it includes almost 1,000 of these clusters of cells that are whole slide images. And the experts have curated, have checked these images, and from these images, they isolated more than 4,000 images of single cells. Both the whole slide images and the single cells has been classified by experts in actually 5 categories. We are most interested in, yeah, we are not interested in the details of these categories, but basically 2 of these categories indicates normal cells, so healthy cells. 2 indicates abnormal cells, that are the coilocytotic cells and dyskeratotic cells, which indicates likely presence of cancer. And the 5th category is benign cells, which is a kind of transition state. Yeah, here we can see an example of the whole slide images and the examples of the 5 type of these cells. So basically, we developed 2 models to classify the whole slide images or the single slide images. For the classification of the whole slide images, basically, we divided the data set in a training set and validation set, and we also augmented the training set because yeah, the images were not so many. We have 773 images in the training set. And at the beginning, we built a simple convolutional neural network to have a kind of baseline based on 4 layers of convolutional layers. Yeah, and yeah. And afterwards, we also tested bigger networks, which were developed for image classification. And they were trained, these networks, on the ImageNet dataset. So we did the transfer learning and then fine-tuning of these networks. Here in the table, you can see a summary of the accuracy of our result on the validation dataset. You can see that all the big network perform better than our simple convolutional network. And the accuracy of the results were very similar. We also look at in more detail. These are the confusion matrices of the results obtained. So on the diagonal, there are the good prediction. On the off diagonals, there are the bad prediction. Yeah, you can see that all the 4 big data sets predict reasonably quite well, and also comparable quite well, while our initial simple network is not bad, but definitely not so good. For the classification of single cell images, we used a similar approach. We had more images here. We did anyway augmentation by flipping up, down, left, right, and both the images. Here also we tested one simple convolutional network and 2 big networks. And yeah, you can see here that the accuracy of the prediction is much better. For the VGG19 network, the accuracy is more than 98%, so pretty good. These are the confusion matrices. Yeah, you can see that also from the confusion matrix, it's quite clear that VGG19 it is performing very well. Here, just for comparison, I put the confusion matrix obtained by that was published in the paper by the author of the dataset, the paper that was connected to the publishing of the dataset. And yeah, you can see that the results that you obtained is comparable or even better than what was obtained in the original from the network published in the original paper. So yeah, and what we wanted to show is not only simple prediction, we wanted also to give the user the possibility to see why, where the prediction is coming from. So we used this explainable AI technique, this called GradCam++, it shows us a heat map, the region of the original image that mostly contributed to the outcome of the prediction. Yeah. In this way, it is possible to see whether the prediction can make sense or not. So how we implemented this in our tool. So it's possible to upload images either of wall slide or single cells. After the upload, you get the classification of the type of cell. And optionally, you can also visualize that GradCam++ map over it to see which regions are more important. And what we wanted to do also is the possibility to select areas, to select single cells from the wall slide images to get a better prediction of the individual cells into wall slide images. So I can show you. So here we can upload either wall slide images or single cell. So we upload, for example, this one. Yeah, this is wall slide images. The prediction is normal, so not indicating not cancer. And yeah, you can see here where the model focused more on to give this prediction. It is possible to select an area of a single cell. Yeah, of course we get similar result. This was a simple example. We can see a more tricky one. So let me check. For example, this one. Yeah, this shows it's almost empty. It only shows 2 cells. We can see indeed that from the tension map that the predictor focuses on these 2. And maybe you can notice that these 2 cells look differently. So the prediction is abnormal, this keratotic. And if we select only one, this is the keratotic cells. And if we go back and we try to select the other one, this is a different kind of cell because in this slide there were 2 different cells. And we thanks our mentor, Imran, which helped us in the development of this tool. And thank you for your attention.